Hi guys, as per the schedule, this is the first ever revision class on basics and AC steady state sinusoidal analysis of network theory. Before going any further, one thing is very important, that is short notes. You have to prepare short notes compulsorily because this year all toppers said the same. Short notes is very crucial. That short notes, you have to, once short notes is ready, you are going to work on that particular short notes only till your settlement in electrical engineering. Let us start with some problems. Here I collected, I started solving problems which I did not solve in our recorded videos. Okay, means let us see one by one. And I'm taking from very basic and gradually we are going to increase the standard. Kind of that. See, if Vx equal to 10 volts, if Vs equal to 10 volts, Is is how much? Is the question. If Vx equal to, it's actually very simple question, kind of diploma guys also will be able to do. Our engineering students, first year students also will be able to do. Anyway, 10 volts, 5 ohms. In this is how much current would flow? 2 amperes, 10 by 5. If 2 amperes current is flowing through this, how much would be the voltage across this? 2 into 4 plus 5, 9 is going to be 18 volts. If 18 volts is across 3 ohms, how much current will flow? 6 amperes. And 18 volts, 6 amperes, it would be fine. And if you apply KCL here, how much current would flow through this? 6 plus 2, 8 amperes. And if 8 amperes current is flowing through 2 ohms resistance, and one more thing is try to have pen and paper, try to practice. Okay. Now, 8 into 2 is going to be 16 volts. And if I try to apply KVL in this particular loop, okay, voltage across this is going to be 16 plus 18, 18, 28 plus 6, 34 volts. And some current will flow through this, 34 divided by 1 ohm, 34 amperes. And current flowing through this is going to be 34 plus 8, 42 amperes. Problem solved. I collected this problem from Hythen Kimmerly. And for the same, try to calculate in a reverse way. If Is equal to 50 amperes, Vx equal to how much? Means we have to keep on continue applying current division rule. That's it. If Is equal to 50 amperes, how much is Vx? Now let us do one thing, current division rule or resistance recombinations. Across this, how much is the resistance, total resistance? 5 plus 4, 9. And across this, if you see, 9 and 3 are connected in parallel. So 9 into 3 by 9 plus 3, 27 divided by 2.25, 2.25 ohm. And across this, if you see, 2.25 plus 2 is going to be 4.25 amperes. So sorry, volts. And after that, 1 ohm resistance is fine. Now, in order to find out current, for example, Is 50 amperes and this resistance is there. Across that equivalently parallelly connected with 4.25 ohms resistance. So let us find current flowing through this. How much is that? Total current into other resistance by total resistance, current division rule. Okay, total current 50 into other resistance 1 divided by 4.25 plus 1, 5.25 is going to be 9.524 amperes. And again here current division rule will come. And I need to find the current flowing through this. In this is total current into other resistance divided by total resistance. Total current into other resistance is how much? 3 divided by total resistance is how much? 9 plus 3 is going to be 2.38. 2.38 amperes. 2.38 into 5 is going to be the answer. So it's going to be 11.9 volts. Let me cross check, yes. Okay. Now this is going to be the second one. Now let us see this. This also I collected from Hythen Kimmerly only. Find power absorbed by Rx. Means Rx value we don't know, but they have given 9 volts voltage across that. Meaning that, can I apply KCL here? Or can I apply nodal analysis here? No. Because in order to apply nodal analysis, current flowing through each and every branch should be known. Okay. But if I think of directly KVL or mesh analysis, for example, if I apply mesh analysis here, in this. And the combination, these two recombinations, we can do 1 into 3 by 1 plus 3 is going to be 3 by 4 ohms. 3 by 4 kilo ohms. Okay. Now, if I think of applying KVL around this and around this mesh analysis, directly, already we know, means we discussed multiple times. If current source is connected at the outermost loop, in that particular mesh, we need not apply KVL. Directly, I can say that I1 equal to 10 milliampere. Okay. Now, if you apply here KVL, I2 minus I1 into 2, I2 minus I1 into 2, because current is in milliamperes and resistance is in kilo ohms. So directly I need not write 2K and all. Directly current will come in milliampere. That's it. So I2 minus I1 into 2 plus directly I can apply 9 plus I2 into combination is going to be 3.3 by 4. Is going to be 0. Okay. In that already I1 I know. How much is I1? 10. Okay. So this is going to be 2 I2 minus 20 plus 9 plus I2 into 3 by 4 equal to 0. So in this, answer would come as I2 is going to be 4 amperes or 4 milliamperes. Okay. Now the moment you know I2 value, how much is Rx? Rx is going to be 9 divided by I2. Okay. 9 divided by 4 is going to be 2.25 ohms. Again, let me repeat. Try to practice yourself. If you just watch the video, nothing will happen. Now, let us think of this. An AC source of RMS voltage 20 volts with internal impedance of something feeds a load of impedance of something in the figure below, the reactive power consumed by the load. Okay. Maybe EC guys may feel a bit of small difficulty, but our electrical guys, reactive power, it's ours. Now, directly let us find the current flowing through it. Okay. How much would be the current? 20 divided by 7 plus 1, 8 plus 4 plus 2, 6i. I got the current. That current value has 2 at an angle minus 36.87. Okay, I capitalize because that's going to be RMS value. Okay, now after that I have reactance value of J4. I square X is going to be the reactive power. Is it absorbed power or delivered reactive power? 7 plus J4 meaning that it should be inductance, right? So 7 plus J4 meaning that it should contain resistance and inductance. Load. So inductance obviously should absorb reactive power or deliver reactive power. Absorb reactive power. So absorbed is going to be I square X. That is going to be 2 square into 4 is going to be 60 VAR. Okay. Now let us think of this problem. This problem also I collected from Hyderabad. Find Zn input impedance when AB are open circuited, AB short circuited. AB open circuited and AB short circuited. Okay. Now let us see omega they have given 4 radians per second. And capacitance can be converted into sinusoidal analysis, right? Xc equal to minus J by omega C. This is going to be minus J2. So this is going to be minus J2. And 4 henries plus J omega L. Omega is 4 radians. So this is going to be plus J 16 ohm. When it is open circuit. This is A and B they have given. Let me consider this as X, this as Y. And in short circuit conditions, in our sessions also, I clearly said whenever you find long short circuit path, give node numbers. That we are going to see later. Okay. Now let us try to draw the circuit from X. This is X for example. From X to A 8 ohms. This is A. And from A to Y. This is Y. A to Y, this is plus J 60 ohms. Two elements are one branch is over. Now if you think of from x to b minus j to x to b, this is going to be b, this is going to be minus j2, and after that 2 ohms will come. So this is going to be 2 ohms. Now you will be able to find out because this is series, both are parallel. So this is going to be 8 plus 16i, inverse plus 2 minus 2i, inverse equal to, total is going to be Zn equal to 2.378 minus j 1.73 minus j 1.73 ohm. Now let us see when it is short circuited, how much it is the impedance. Okay, now we have to short circuit, right? So if you short circuit these two, let me think of this as x, this as y, and if this is a, this also will be a only because long short circuit paths. Okay, now again same old story, 8 ohms, 4 henries, in the sense this is going to be a 16, this is 4, this is 8 ohms plus a 16, and this is going to be minus j2, there is going to be 2 ohm, because this is a, this is b is nothing but a only. What does it mean? These two are parallel, and both are connected in series. Okay, so 8 and G2 are connected in parallel. So 8 inverse plus minus 2i inverse. Okay, after that 2 inverse plus 16i inverse. So net is going to be Zn equal to 2.439 minus j 1.636. That's it. Okay, but here though it is simple, directly questions cannot come in GATE. It's simple only, right? Because complex mode calculations are required, so it will consume more time in GATE. Okay, now let us take this. To electrical circuit, it is very popular question. Okay, 10 means we need not read and all. Directly 10 volts they have given, 5 volts they have given, and resistances they have given, and they are asking then voltage across 15 ohms resistor they are asking. Let us assume that, of course, they should have given plus minus symbols like this or plus minus, because already we know that for every voltage without polarities, voltage should not be positive. We should not represent voltage. Means each and every voltage should be represented with polarities. Each and every current should be represented with directions. Right? Now, coming to the point here, they are asking voltage. See, 10 volts, 5 ohms. In the sense 2 amperes current should flow through this. And 5 volts, 1 ohm. In the sense 5 amperes current should flow through this. Okay, so 2 is entering here. This is one complete network. This is one complete network. Okay, so in this complete network, through this branch 5 amperes is entering, through this branch or 2 amperes is entering. So compulsorily return current in this direction should be 5 plus 2, 7. So this is 7 amperes. Okay, so if it is 7 amperes, already we know that. Okay, let me write it here. This is 15 ohms resistance and 7 amperes is going like this. So already we know that whenever current is entering at that particular terminal, we are supposed to keep positive because it is passive element. Okay, so this is going to plus, this is going to minus. 7 into 15, 105, right? 70, yeah, 105 volts. But they asked, actually they should have asked in that way, of course. They did not give plus minus polarities, but if we assume plus minus polarities like this, it is going to be minus 105 volts. Okay, but in this particular question, plus 105 or minus 105 both should be right because they did not give plus minus polarities. Now take this for the circuit in figure. Okay, something like this. Can I apply superposition theorem? Non-linear. Okay, so the moment it is non-linear, we are not supposed to apply superposition theorem. Now, first of all, we should understand that this particular diode, is it in forward bias region or reverse bias region, such that if it is forward bias region, obviously we electricals are they did not give any information. We assume that if it is forward bias, it will behave like a short circuit, otherwise it will behave like a open circuit, right? Now, first of all, we should understand whether it is forward biased or not. So without touching this block, we should be able to work out and we should be able to find out whether that particular branch or that particular diode is it in forward bias or reverse. Definitely we can apply Thevenin's, but Thevenin's theorems and all not in this particular week, right? Next week we plan. So, but source combinations we know. And this is 4 volts they have given. Okay, in the cutting it went. Now if I convert that into source recombinations, so this is going to be 4 by 2 amperes, and in parallel with it 2 ohms, in parallel with it some kind of diode and resistance. And if I convert this again into what they say source recombinations, plus is here, see 2 ohms in parallel, 2 ohms in parallel, and here current will be downward direction. Okay, that is going to be 2 by 2, 1 ampere will be in downward direction. Okay, now if you see this particular node, current source recombinations, 2 ampere is entering, 1 ampere is leaving. So recombination or equivalent is going to be 1 ampere. So this is going to be 1 ampere. 2 amperes entering, 1 ampere leaving. So net is going to be 1. And 2 and 2, 1 ohm. And now if you see this diode, what is this resistance? 2 ohms. Okay. Now directly we can say that it is in forward bias. Now try to find out the current flowing through this and then try to find out the voltage. Solve. Okay. Now how much is this current? Again total current into other resistance divided by total resistance. So current is going to be total current 1 into other resistance 1 divided by total resistance 3, 1 by 3. How much will be the voltage across this? 2 by 3 into 2. Okay. Now let us think of this. A network contains linear resistors and ideal voltage sources. See here, ideal voltage sources. Because if it is a current source, answer would be different. If values of all the resistors are doubled, then the voltage across each resistor. Let me take one example. Maybe this is 10 volts. And here, let me think of 2 resistors of 1 ohm, 1 ohm. Okay. Now, how much is the voltage across this 1 ohm? 5 volts. 5 volts. Now, then the voltage across each resistance, meaning that I am going to double this. If I double this to 2 ohms, if I double this to 2 ohms, then also voltage across that will be same. Okay, but if you think of with current source, problem will be different. If I think of this as current source, that's why clearly they specified voltage sources. If I think of this as 1 ohm and 1 ohm, if I think of this as 5 amperes, how much will be the voltage? 5 volts. But if I increase the resistance here, if I increase this to 2 ohm, if I double the resistance, if I do this to 2 ohm, it would be 10 volts. Right? Voltages are going to be changed, doubled. So that's why they clearly mentioned voltage sources. With voltage sources, even if you double all the resistance values, resistor values, means voltage across each and every resistance remains same. None of the above are not changed. Now see this. Means VA minus VB is 6 volts. VA minus VB. So plus here, minus here. VA with respect to B, A voltage. With respect to B, A voltage is 6 volts. Then VC minus VD. VC minus VD. VC minus VD. With respect to VD, at what potential VC is working. Now this is one network. Already previously we have taken, right? 2 networks, 3 branches. And this is one network. Now current entering in this direction is 6 by 2, 3 amperes. So ultimately the moment current is entering from here, actually this can be directly connected with 3 phase. Anyway, next week 3 phase will come. Okay, 3 amperes is entering. So current leaving through this should be 3 amperes. Okay, now if it is 3 and already 2 is entering to the same node, so 2 plus 3, 5 amperes will go. Okay, so if current flowing through this is 2 plus 3, 5 amperes. So answer would be, see here, plus minus 5 volt will come. But VC minus VD they asked, so it would be minus 5 volt. Okay, you understand my point, right? See, this is 1 ohm resistance and 5 ampere current is flowing like this. So plus minus 5 volt will come. But this is VC, this is VD. They asked VC minus VD. VC minus VD, meaning that plus minus. What is VC potential with respect to VD? Will give you minus 5 volts. Okay, now let us see this problem. The dependent source shown in figure delivers absorbs. See, they are saying V1 by 5, but frankly, is it a dependent source? No, it is actually working like an independent source because this V1 is V1. So the moment V1 is going to be constant, directly 20 volts, V1 by 5 also is going to be 4 amperes directly. 4 amperes directly. Okay, I need not actually apply KCL, KVL, some kind of stuff in order to know how much current is being shared by this. Directly 20 volts, which is going to fix, you cannot change. So 20 divided by 5, 4 amperes, you are not going to change. Now, we have to find out voltage because current I know, voltage across this has to be found. In order to find out the voltage, which is better, mesh analysis or nodal analysis? Now, if you apply nodal, because all the time logic is which is better to apply, mesh analysis, because we should not be habituated with mesh only or we should not be habituated with nodal only. Depending upon the situations and circumstances, nodal may be better or mesh may be better. Now, if I go ahead with nodal, if I think of this as reference and this is going to be V1, but with respect to reference, it's already connected. Means ideal voltage source is connected. So directly 20 volts I can write. Okay. Now this is going to be V. And that's it. Okay. So V has to be found. So how many nodal equations will come? V minus 20 because this is ideal voltage source which is connected with respect to the earth or neutral point. Okay. Or common point, whatever it may be. So V only has to be found, meaning that only one equation we have to write. Let us apply mesh. Okay, if I apply mesh, first mesh, second mesh. Now, in the first mesh, equation can be written, but in the second mesh, because ideal one current source is connected to the outermost loop, meaning that in the concerned mesh, we need not apply mesh analysis. So directly I2 equal to minus 4 can be written. I2 equal to minus 4 can be written. So if you go with mesh analysis also, only one equation. If you go with nodal analysis also, one equation. Now again, which is better? Because from equations point of view, both are same. Okay. Now equations point of view, both are same. Now let us think of which is better. What is output requirement? Current is known, voltage is the output requirement. So directly voltage can be found by applying nodal analysis. So apply nodal. V. Okay. V minus 20 leaving current. Already we know, right? We have taken leaving currents as positive. Because voltage drop we are going to consider as positive in order to match with the duality and all. Anyway, V minus 20 by 5 plus V by 5 leaving current plus are equal to, because this is entering current, equal to 4. Okay. Apply for V. V by 5, 2V by 5 minus 20 by 5, 4 plus equal to 8. So V equal to 5 into 8 by 2. So it's going to be 40 volts. Okay. Now, what is the power absorbed? What is the power absorbed? Voltage equal to 40. 20 volts. 20 volts. Okay. Now, voltage across this is 20 volts. And the current is coming out of positive terminal, meaning that it should deliver power. Okay, absorbed power is nothing but voltage multiplied by current entering into positive terminal. Delivered power is nothing but voltage multiplied by current leaving positive terminal. Okay. Now, what is the delivered power? Power delivered equal to voltage multiplied by current. Current already 4 amperes by now. We know. So 20 into 4 is going to be 80 watt is going to be delivered power. Delivers 80 watt. Now let us see. In the circuit of figure, the value of the voltage source E is. They are asking E. Okay. And each and every terminal are at different potentials. Now let us take one common point. Okay. Let us take one common point. Total, a kind of reference. Okay. If I consider this as reference point, now 0 volts, so short circuit. And here 10 volts, meaning that with respect to some reference, this is a 10 volts. So this is plus minus 10 volts because this terminal is connected at 10. Now this terminal is connected at V1. So with respect to reference, this is at a higher potential of V1. And this is at V2. So with respect to reference, this is at higher potential of V2. Okay. Now E has to be found. Now apply KVL around this. Minus E. Because I already told you, if you touch minus first, use minus. If you touch plus first, use plus. Okay. Now I touch minus first in applying this. Minus of E. Or to the other side, E equal to minus 1, minus 10. I touch a minus. Again I touch a minus. E is going to be minus 16 volts. Okay. Now let us take this. It's also a very good question. Because directly by seeing that, we may feel it is very difficult. A kind of, which need too much of calculator actions, okay? But it is actually very simple. See here, in the circuit shown below, current through the inductor is. Current through the inductor is. Direction already they are specified in this direction. Now, means should I go with mesh or nodal or kind of stuff? If you think logically, see here, if I think of this as X, from X, minus 2 plus, voltage rise of 1 volt, plus 2 minus, voltage drop of 1 volt. So from here, voltage rise of 1 volt, voltage drop of 1 volt. Meaning that from here to here, there will be no voltage difference. No voltage difference in the sense 0, short circuit. Short circuit is a 0 volts voltage source. So this and this can be directly connected. Now, see, the logic is so simple. If I think of this as maybe A or maybe Y, X is taken here, no? Y. And this is X. Now, this 1 ohm is connected between X and Y. This J1 also is connected between X and Y. And the current entry is 1 ohm. So, 1 ampere. So, current entry is 1 at an angle 0 ampere. And this is Y terminal. And from Y to X, 1 ohm, this is X, and again Y to X, J1 ohm, and combination. So if they are asking current flowing through this, or maybe RMS value. Okay. Now how much is the current? Again, current division rule. Total current into other resistance divided by total resistance. So current through this, maybe IL equal to total current 1 at an angle 0. Into other resistance 1, other resistance, other impedance, divided by total is going to be 1 plus J1, which is going to be 1 by 1 plus J1. Okay, so 1 by 1 plus J1, 1 by 1 plus J. This one is the right answer. Okay, it's actually simple thing only, but I thought of revising. The circuit shown in figure represents. See, this is current II and AI or AI into II. Is going to be current source. This current source, that particular output of the current source or current shared by it is depending upon current. So it is going to be current dependent current source. Okay, it is current dependent current source or current controlled current source. Now let us consider this problem. The circuit shown operates at 50 H. Find complex power absorbed by the inductive branch and value of capacitor C if QC is 10 VAR. Already we know, right? Like our capacitor always deliver reactive power, inductance always absorb reactive power. Anyway, our if you think of capacitor value, reactive power delivered QC is how much? 10 VAR. And there is nothing like resistance and all. Vi sin pi or pi is going to be, sin pi is going to be unity. So Vi is going to be 10. And how much is voltage? 20 volts. So I is going to be 10 divided by 20 is going to be 0.5 amperes. In the sense, current flowing through this is going to be 0.5 amperes. Okay. Now, if current is 0.5 amperes, how much will be that X? X is going to be V by I. 20 by 0.5 is going to be 40 ohms. If capacitor reactance value is 40 ohms, then we have to find out the capacitance value. Okay. What is capacitance? 1 by 2 pi Fc. Directly calculate C value. The C value is going to be 50 H they have given. Right. So, into 40 gives 79.57 micro. 79.57 microfarads. One problem is done. Now let us focus on the second. Okay. In the second, they are asking how much is the complex power absorbed by inductive branch. This is 1 millihenry. In the sense, how much is going to be XL plus J 2 pi F, right? Or omega L is going to be how much? L value is 1 millihenry. So this is going to be 314.314. So plus J 0.314 ohms. Across the branch already we know voltage. We have to find out the current and then complex power. So my inductive branch is going to be altogether 1 plus J 0.314 ohms, 10 volts. So 10 divided by that current. 10 divided by 1 plus 0.314 I. Current I got. So I got current as 9.1 minus J 2.858 amperes. Into voltage, of course, complex conjugate has to be done. Because already we know, right, with respect to inductance, if you have inductive reactance plus resistance, current will lag. But in order to calculate complex power, VI complex conjugate will come. Okay, so means ultimately, okay, let me write here. Total apparent power absorbed is going to be VI complex conjugate. So this into 10 volts, right? So this is going to be 91.025 plus J 28.58. This is so much of VA. About complex conjugate and all multiple times we discussed in our areas, right? So current value with respect to voltage, current lag. If current is lagging behind, then reactive power is going to be positive such that absorbed reactive power by inductance is going to be positive. Now let us think of one more. Now see this. In this, a resistive load is connected. Let me make it bigger a bit. Yeah. Resistive load is connected in series with a choke of internal resistance of 5 ohms across 400 volts. 58 supply. A current of 20 amps is passing through load having voltage of 100 volts across it, the value of inductance and power factor of the circuit. Now, input they have given across 400 volts, 58 supply. And they connected through choke. Choke will have resistance also and inductive reactance also. And to that, resistive load is connected. Resistive load is connected. And this value is 5 ohms they have given. And reactance value we don't know. The current of 20 amperes is passing through the load. 20 amperes is passing through the load, meaning that 20 amperes will go through this. And the value of inductance and power voltage across this is 100 volts they have given. Simple. Now 100 divided by 20 is going to be 5 ohm. Okay. And how much is the impedance seen from here? See, impedance seen from here, impedance value directly is going to be 400 by 20. So impedance seen across this is going to be 400 by 20 is going to be 20 ohms. That mod. If you think of division, if I think of, let me take this as XL. E is going to be 5 plus 5, 10 square plus XL square under root. Find out XL. If I find out XL, 300, 400, 300 under root of 300. So 17.32. 17.32 ohm. That is the reactance value. But they asked the inductance value. Means you have to convert that in inductance. That's it. 50 ohms, 50 H already they have said. So is going to be omega L or 2 pi FL. L value is going to be divided by 2 pi 55 milliamperes. 55.13 milliamperes. And if you have any other doubts also, keep on sending to the mail gate.knrao, such that anyway you are getting the replies and all within 24 hours. But if any good questions are there, in this way we are going to pick it up and we are going to discuss. Okay. Now this is L value we found. What else they asked? They asked anything. The value of inductance is over and the power factor of circuit. What is the power factor of circuit? X value already we know 17.32. So the total impedance value is going to be 10 plus J 17.32. Calculate the angle of this and calculate the cos of that. You are going to get the power factor. $60 degrees. So power factor is going to be 0.5. Got it. Power factor is calculated across the source. Because across the load already it is unity power factor, right? Because that is resistive load. Now, let us think of one more problem. Take this. Why I have taken this problem is, when I asked to one of our team members, they told me that, sir, this particular star, 100, 100, 200, let us convert it into delta, then problem will be easy. No. See the problem here. 100, 100, 100, star connection. Sorry, delta connection. Okay, it means 100, 100, 100 delta connection. If you convert it into star, it will be very easy. Rather than focusing here on the star, focus here on the delta. Because 100 by 3, 100 by 3, 100 by 3, that would be easy, right? So, from here, 100 by 3, from here, 100 by 3, from here, 100 by 3. Easy. Now, 10 volts, 100 by 3, and after that, 200 by 3 will come, 100 by 3, 200, remaining 100 by 3 is going to be again 400, 400 equivalent is going to be 200. Okay. Now, let us draw the equivalent circuit. This is 100 by 3, right? This 100 by 3, and after that 100 by 3, 100 by 3, 100 by 3, 400, 400, 200, and after that this 100 by 3, 200. This 100 by 3, 200 volts. This is going to the circuit. In this circuit, where you have to find out the voltage, output voltage, V0 across 200. Because 400 and 400 are connected in series. Okay. Now, 200, 100 by 3, 200, 100 by 3. Net is going to be these two are connected in series, these two are connected in series, net are connected in parallel. So, net resultant is going to be, let me change the color. 100 by 3 plus 200 divided by 2 plus 100 by 3, 150. So, equivalent impedance across this particular voltage source is going to be 150 ohms. And what is the voltage? 10 volts. Now, try to calculate current. So, 10 divided by 100. Some current. Okay. Now, that current will be equally divided because the equal impedance divided by 2. And that particular current into 200 is going to be the voltage across this. Into 200. 6.667. That's it. Okay. Directly just by seeing delta and star, directly don't go because most of the times, see, then it will be easy. Okay. Let us take one more. Find energy stored in capacitance and inductance. We are supposed to calculate capacitance, stored energy, inductance, stored energy. Right? Now this is DC. The moment it is DC, capacitor will behave like open circuit and inductance will behave like short circuit. So this is under steady conditions. Of course, transients, later it will come. Once it reaches steady state conditions, it will behave like open, it will behave like short. right? Now let us focus on capacitance. The moment it is short, same 30 volts will come across 30 ohms because inductance is short circuit. Now if you divide, because this is open circuit, right? 30 volts has to be divided between 10 and 20 ohms. So this is going to be 20 volts. So voltage across this plus minus with respect to this 30 volts, with respect to this same 20 volts. So this is going to be 10 volts. Done. Now energy stored. Energy stored in capacitance is going to be half CV square, right? Half C capacitance V square 10 square is going to be 50 joules capacitance. Now let us think of inductance. Now in inductance, this is open circuit. Current will go, this is short, it will go like this. How much would be the current here? Because half Li square, no, it is going to be 1 ampere. So energy stored in inductance is going to be half L 1 Henry I 1 square is going to be 0.5 joules. Okay. Now let us consider. Okay. Sorry. Yes. Let us consider this. Means we are going to go with the generalized approach, such that later it will be easy for you. Anyway, the lamps of 60 watt 230 volts and 100 watt 230 volts are connected in series across 230 volts 50 height supply. What is the power dissipation of both the lamps? See here, already both the lamps are rated for the same voltage. Okay, same voltage. Now, point here is lamp is nothing but a resistor. Means that's what we say in our machines also, power systems also. Lighting loads, we say lighting loads in the sense unity power factor loads in the sense unity power factor load in the sense pure resistance is going to be. So means from here, let us find out the resistance, and that resistance, both the resistors are connected in series. That's it. Okay. Now, for example, if I have some rated voltage V and this absorption is P, then how much is the resistance here? This P equal to V square by R, right? So P equal to V square by R, or R equal to V square by P. Now for this, first resistance and second resistance, if you see, same voltage, no, same voltage. Because this particular thing can be followed only when voltages are same. If voltages differ, then in that conditions, these particular values also will differ. That's it. And P1 V square by P2. Okay, for the second lamp. Now, if you think of both are connected in series, R1, R2 are connected in series across again same voltage, 230 volts. So this is going to be R1, this is going to be R2. How much is the power absorbed by this? V square by R1 plus R2. Now V square by R is the resistor, sorry, power, right? So power is going to be V square by R1 plus R2. Okay, so that is going to be, see here, this is going to be R1 plus R2, right? V square by P1, if I calculate R1 plus R2 plus V square, same voltage, P2, or I can say that V square 1 by P1 plus 1 by P2, right? Now use the same R1 plus R2. In place of R1 plus R2, if I use that, so this is going to be V square by R1 plus R2, V square into 1 by P1 plus 1 by P2. And especially in ESC, most of the cases you don't get any paper without lamps question. Okay. Anyway, V square will get cancelled. So net power is going to be 1 by P1 plus 1 by P2 inverse. It is equivalent to connecting resistances in parallel. Okay, if you connect resistance in parallel to R1 and R2, net equivalent resistance is going to be 1 by R1 plus 1 by R2 whole inverse. In the same way, this also. So net power is going to be first 60 and after that 100, right? 60, 100, right? So 60 inverse plus 100 inverse equal to inverse. 37.5. 37.5 watts. Okay, that's fine. And one more thing is, see here, when voltages differ, try to take that and individually find R1 and R2. That's it, right? For example, if they give 230 volts for this and 220 volts for the second one, then what you are supposed to do, calculate R1 with 230 square divided by 60. and calculate output with 220 square. Here 230, here 220. 220 square divided by 100 power, and as per that you can do. It's simple resistance. Whatever it may be, Lamb's problem, you have to convert into resistance, and that resistance should be used. That's it. Now, let us take this problem. Actually, this was given in GATE for 1 mark. See, maybe people may feel that it is difficult and all, but if it is difficult, how would they give for 1 mark? Now, let us see. See, here 200T, 500T. Two different frequencies are there. When two different frequencies are there for the reactance elements, okay, the moment reactive elements are there, compulsorily we can use only one, that is superposition. Okay, with 200 we have to do it separately, and with 500 we are supposed to do it separately. Now let me, so let me do here with only 200, and I'll take the 400 problem later. Now with the 200, how this is going to behave, how this is going to behave. Okay, so 0.25 Henry, omega L, right? Omega equal to 200. So 200 into 0.25 plus J50, because for inductance plus J will come, and all already we know 50, and 100 micro, 1 by minus J by omega C, right? So 200 into 100 micro inverse minus J50 plus J50 minus J50. Short. Okay, the moment it is short, independent of this, directly, because it's equivalent to Vi for one frequency I'm analyzing here, that frequency is 200. So this is Vi, this is short circuit output. Maybe here whatever it may be, already I told you, if anything is connected across ideal voltage source, that branch need not be considered in voltage calculations, because the moment it is short like this, means across voltage source you connected one shunt branch. Maybe power means even if I remove this, in voltage calculations nothing will happen. But in current calculations of this particular source or power calculations of this particular source definitely will vary. Okay, but the moment any voltage source, across voltage source, ideal voltage source, if shunt branch is connected, we can remove the shunt branch for the calculations of voltages, or for the calculation of mesh analysis, or for the calculation of KVL. We discussed that. Now it is going to be same input will come. Now let us think of here. Maybe let me consider only 500. Okay, if I consider only 500, let us think of the same, because with 200 plus J50 minus J50, with 500 definitely these two will differ. Okay, now coming to this point, means some impedance will be there. Now let us focus here. For 10 micro, how much is the 10 micro into 500, 200. So this is going to minus J 200 ohm, and 500 into 0.4 plus J 200 ohms. Okay, so this is plus J 200 and this is minus J 200. If you calculate impedance, it is going to be infinite, and if you calculate admittance, it is going to be 0, meaning that it will behave like a open circuit. If it is open circuit, again let me draw equivalent. So some impedance is there here, kind of this impedance, and with respect to 500T. So Vi of 500T related frequency, and here it is open. How much will be output voltage? Output voltage will be same, because not there. So if Vi, see here, in this case 200T means because of short circuit, completely 2 cos 200T will come here. And if you think of here, 4 sin 500T, 4 sin 500T will come here. So what is the output voltage? Output voltage is same as Vi, same as Vi. Okay, so ultimately output voltage is nothing but input voltage in both the frequencies. Superposition with different frequencies. There is no other goal. Okay.